So in general, we'll be dealing with discrete numerical probability distributions for our Year 11 work. In Year 12, we'll look at some more continuous numerical data. So I've got an example here to show you how to set out a probability distribution. Now, distribution just means spreading out, and so we're literally just putting what we know in a table. Now, we set it out so that we have little x, or whatever we define as being the possible outcomes on the top. So here we're tossing 4 coins, and we're letting big X be the random variable. So it will be, in this case, the number of heads that we've recorded. So generally that will be specified. Instead of just saying what could happen, if there's a bunch of things that could happen, we need to define what it is we're going to use as our parameter. We could have said let X be the number of tails recorded equally. Now we're going to list all the possible outcomes, and we call those little x, and we place these along the top. So if we're throwing 4 coins, it makes sense we could get anything from 0 up to 4 heads. Then we calculate the probability that x is in each possibility. So what are the chances of getting 0 heads? Now, a lot of the time, our Chapter 10 work looked at actually making probability tree diagrams and working out these probabilities. In our work in Chapter 11, we're looking at the distributions. A lot of the time, these will be given to you. But just to show you that with an example like this, even though it's a little time consuming, you could make a tree diagram showing 4 different coin tosses, and the fact that there would be 16 outcomes. And of those 16 outcomes, only one of them would have 4 heads. So the chances of that would be 1 out of 16. And the opposite of that, 4 heads would be no heads at all, which would be 4 tails. Now you can see that there's going to be symmetry here, because getting no heads and getting 4 heads is the opposite of getting no tails and 4 tails. Similarly, if you've got 1 head out of the 4 coins, that would be the same probability as getting 1 tail, which of course is 3 heads. So you'll see that the probabilities of getting 1 and 3, which you can count up, there's 4 ways of getting each of those over here, are exactly the same. And then the most likely thing that's going to happen is getting 2 heads, because there's 6 different ways out of the 16 that could happen. Now when we set this probability distribution up, it sort of makes sense, if you can, to keep the denominators of your fractions the same, so that then you can quickly do a little add up here and just double check that the total actually does come to 16 sixteenths, which is 1, or a certainty. Now we can actually graph a probability distribution, and that's what a lot of our next section of work will be about. So it makes sense that along the x-axis we're going to put little x, because that's the parameter that's going up that we can clearly categorise. And then on the y-axis we put this whole thing, which here means the probability that big X is little x. Now let's just have a think about what that means. The probability that big X, in other words, the probability that the number of heads is little x. So what that means is, what's the probability that the number of heads is 0, or 1, or 2, or 3, or 4. So little x can take these different values, and this is the probability that what we get is each of those possibilities. So you can see that when we graph this here, and you can just pick a scale. Here I needed to go up to 6 sixteenths, so I've put that as my top point. I've got these points here. And that's making a graph now of my probability distribution. Now, sometimes you'll have probabilities that are all different like this. Let's think of a different scenario. For example, perhaps if we were to toss a coin, let's roll a die, and let's think of all of the things that we could get. We're not going to get 0. We could get 1, 2, 3, 4, 5, or 6. And here we would have just x. It's not the number of heads, this is just the number shown on the die. Now, what are the chances when I roll a die that I'm going to get a 1? It's 1/6, isn't it? And in fact, all of these will be 1/6. So this happens quite often, and we call this a uniform sample space, or a uniform probability distribution. And the reason it's uniform is because they're all the same. So if we're to graph this one, obviously we'd only have 1/6 down here. Let's say we've got a different sort of scale. And we would have, well, nothing on 0. Let's just keep the same numbers that we've got here. And we'd have all our data points being along in a row like this. We'd have to go up to 5 and 6, obviously, and they'd go along like that. So that sort of thing could happen. You can have something that's completely flat as your graph of your probability distribution.